Thanks so much for joining us today on our first Sys Talk webinar session. My name is Janelle Hansen, and I'll be moderating today's session. And I'm being joined today by three guests. And I'd like to take a minute just to introduce you to who we will be talking with. First is my colleague. Her name is Lamia Abdelfatah. She's an urban planner and researcher working with Systematica in the areas of mobility research and communication. She has a background in collaborative urban development and expertise in issues of spatial equity in cities, with a particular focus on gender equality. Since joining the team in 2019, she's been involved in diverse projects and publications aimed at sustainable, innovative, and equitable tools in the field of urban mobility. Next, we'll be joined by Sean Turner. Sean is a senior research engineer at TTI, where he has developed, conducted, and managed applied research for 30 years. Sean is a nationally recognized expert with practical experience in multimodal travel, data collection and analysis, performance measures and monitoring, and mobility analysis. He has pioneered using private sector GPS probe traffic data for mobility and reliability performance monitoring. Sean works with FHWA, state and local agencies to advance the use of best available and high quality data in planning, performance management, and traffic monitoring. In the past decade, Sean has led or been involved with several national performance monitoring efforts, including FHWA's National Performance Management Research Dataset, analytic development and testing, and guidance for the MAP21 system performance measures, as well as FHWA's Urban Congestion Report. Next, we have Andre Galli. He has a strong background in design from the Politecnico di Torino, pardon my Italian for this, and innovation management with Scuola Superiore Sant'Anna. I hope that's correct. Andre is the Director of Strategy and Development at Accurate and teaches computational design as an adjunct professor at the Politecnico di Milano. Formerly project leader with Carlo Ratti Associates, over the last 10 years, he has been testing the impact of data-driven approach to projects, bridging between the urban environment and the digital one. So with that introduction to our three guests, I'm going to kick it over to Lamia, who's going to do a short presentation on her research. Lamia?
Thanks, Janelle, for this introduction. Let me share my screen. Can you see the screen now? Okay, perfect. So to start off, I'm going to present the research focused in a book, which is part of a series of publications produced by Transform Transport, which is the research unit of Systematica. These books tend to focus on thematic areas in mobility and specific contexts in which Systematica has had extensive experience. And in this case, this book combines both the thematic approach and the contextual approach. So it focuses on the US, to be specific, focusing on primarily on the versatile use of data in detecting mobility trends. So the screen you see here is just the aim of the book. Let me just highlight a few main points. So basically what this book tries to do is look at mobility trends of forward-looking cities, and I'll explain a bit more in the next slides what I mean by that. Using data, including standardized data sets, but also location-based data, to try to imagine the potential directions of the future of mobility in the country. It's important also to note that this research was produced just before the pandemic, so kind of at the brink of a turning point. Which is interesting because it kind of defines, it sets a snapshot of the mobility landscape before the pandemic hit, which is an asset in itself. So first off, this is the table of contents of the book. It's divided based on the process of analysis, moving from the methodology, criteria to the analysis and so on. I will only show snippets of the book just for time purposes. But what I want to focus on mainly is the third and fourth chapters, which are the core of the analysis. They follow different approaches. So in the third chapter, what we try to do is we follow a symptomatic approach, meaning that we start from ideas of specific problems that could, for example, be something that is contested in mobility today, and we look at the data to try to confirm these problems or to devalidate them. On the other hand, the second chapter takes a systemic approach. So instead, we look at a volume of data and we try to see if we can detect specific trends in these data. So in order to do this, we had to look at a huge amount of data that, as I said before, is both from standardized data sets, but also using location-based data from GPS devices of cars in particular, to be able to adopt a more granular approach and a wider spatial understanding of the data. One thing I want to say, just heads up, this, like I said, the book was produced before the pandemic. But what I want to also emphasize here is that big data is often perceived as the end of theory, because technically you have the data before you have the causality link. So before you understand why the data is the way it is. But what we try to do in this book is kind of combine the approach of kind of probing through data and probing through theoretical ideas that we already have. So these are the 5 main cities that we focus on in the analysis: Austin, Savannah, Denver, Seattle, and Los Angeles. And the way that we chose these cities was that we combined the growth metric, city growth metric is what we call it, where we focus on particular areas of transformation in cities and look at cities that have good positive growth rates with respect to these areas. As you can see here on the left-hand side, the growth structure differs from one city to another. So in a way, we are also looking at diverse types of cities, but all with positive indicators of growth and of mobility behaviors. So one of the things that we studied was the modal choice shift. So what's happening here is that we looked at the modal split for different types of modes, but also different age structure. And the interesting thing here is that we discovered that young people don't necessarily use the car less than their older counterparts, as we are sometimes led to believe. But they are more multimodal, so this means that they do use public modes and rely on active modes more frequently and more in higher shares than older generations. Of course, telecommuting is a huge topic since the pandemic, but it's interesting also to see that it had already been rising before the pandemic, and between 2006 to 2016, it nearly doubled in the US. But what was also interesting to find was that older people, for some reason, tend to do smart working more than younger people in the United States, and this is before the pandemic. And this is just something to open up the idea and to kind of track where these trends will settle in the next years. So moving on to the second part of the analysis, where we focus on trip traits and where we mainly do this using the location-based data. So the types of trip traits that we look at are trip length, trip purpose, movement density, weekend movement, and looking at external versus internal trips. I won't cover them all just for the purposes of time. But what I want to emphasize here is that the approach we take here is that we don't look at the city in its entirety, but rather focus on specific zones that have particular characteristics, socioeconomic trends, and the trip characteristics in order to be able to compare between them. So this is just an idea of some of the data we looked at. For example, age group, we find that downtown and university zones tend to have younger age groups, whereas the residential areas tend to have higher age groups. And this is how we kind of create this contrast between different types of zones within all of the cities to be able to compare them transversely. So looking at the first characteristic, which is trip length, first of all, it's interesting to see here on the left, on the right-hand side, that even though there are various differences between these 5 very different cities, we see that the patterns of the trends progress in the same way and are more or less similar, apart from the fact that we see that the peak of the curve progressively changes from the middle section of the graph to the ends as we increase the trip length. Another thing that's also interesting to note is that when it comes to travel time, and of course this is a topic that we maybe focus more on since the pandemic, given, like, for example, looking at the idea of the 15-minute city, just this idea of chronocentric urbanism and putting time at the center of planning. It's interesting to see that groups that tend to have higher time poverty, if we could call it that, also tend to travel for longer times than their counterparts across the spectrum. So, for example, the correlations show that people living in large households, in low-income households, tend to travel for longer times. The exception here is Los Angeles, where perhaps unsurprisingly, we see that travel times tend to increase across the various aspects. Just to kind of focus the study a bit and to show what the use of such data can be for urban planners, here I just show Seattle's data for trip length and trip purpose. Like I said, we see that short trips tend to increase or to reach their peak during midday in the university and downtown districts. Whereas at the same time, if we look at trip purpose, this same time of day is the time of day where the majority of trips are actually non-home based. So tying these two pieces of information together, urban planners can set a specific mobility strategy for these areas where perhaps micro-mobility options and short-range non-motorized transport options can be the primary mode of transport. This is also seeing that if we look at movement density, we know that downtown areas tend to have significantly higher movement than other areas of the city. In the case of Seattle here in particular, we see that downtown is about generates about 17 times the city average. So again, piecing all of these pieces of information together shows us how much location-based data can be a tool for a targeted approach, speaking both spatially and socioeconomically for mobility. And then finally, just to wrap this up, so mega scale changes and shifts such as the one that we're in right now tend to expose just how fragile our forecasting tools are. This is one thing, but also on the other hand, it's important to note that it's vital for big data to be accessible, but not just to be accessible in a format that we can manipulate it and be able to combine it in different ways for it to reflect new readings and to always present new data. In a world where data is really everywhere and it's omnipresent, it's important to be able to read the data in new ways all the time in order to be able to unlock its full potential. And that's it. Thank you.
Thanks, Lamia. And just to, I don't know if it's really small on the bottom, but just for the audience, you know, this last chart that she's showing is actually the VMT that we found, you know, kind of striking that you see what it was in February 2020, and then COVID hit, and then that huge drop. So I think that this is a data point that, you know, certainly showed us what can happen when a pandemic strikes. So I think, yeah, just so you can, probably hard to read that at the bottom. Yeah. But thank you, Lamia. It was really great.
Thanks, Jenna.
Yeah. So with that, I'm going to hand it over to Sean, who's going to present to us a little bit on the work that he's doing at TTI. I gave already the nice introduction for Sean. So Sean, whenever you're ready, take it away.
Thank you, Janelle. Appreciate that. And I don't know if this isn't going to be in my presentation about transportation, but y'all may have noticed that we're working on some cloning here at TTI, and there's been several, my apologies, there's been several Sean Turners that have logged in because I noticed in my email that several colleagues wanted to join. I sent them my link and didn't realize that I shouldn't share. Anyway, welcome to all the other Sean Turners out there. Pleasure to join you today, whatever time zone you may be in. Janelle was too kind to mention it in my long introduction. You should have asked me for a shorter introduction. That's it. But so here's the thing that you need to know about me if you haven't figured it out from my background. I'm a data nerd to my core, and I'm not embarrassed to admit it because it seems a bit in vogue these days. Data scientist is one of the hottest new job titles. So I've been at TTI for about 30 or so years. I don't spend much time wading through data. That tends to be the younger whiz kids who can probably code 10 times faster than me. I'm mostly developing and helping execute various big data strategies across the different research areas, like some of the ones that I'm showing here on my title slide that we have here at TTI. Today in my presentation, I want to focus on the end user, whether it's our client, our customer. In the research realm, we call it a sponsor, or our data users. So here's a really important lesson that I've learned in the past decade of dealing with big data. And it took me a few years for this to sink in, but I want to slow down and emphasize this point. Not everyone loves data as much as I do. Not everyone loves sifting through it and munging and exploring and just generally rolling around in data. And we need to understand that whenever we build analytic tools for other people. So that's what my presentation is going to focus on. I want to give a little bit of background for those that don't know much about TTI, just two short slides. So TTI, Texas A&M, we're part of the Texas A&M University system. We're almost entirely contract research. We've got about 400 or so researchers that compete through research proposals and interagency contracts with other public agencies, like, for example, the Texas State DOT. We work with other state DOTs. So we are part of a university system, so we employ several hundred students, and we really take education and workforce development seriously. And in fact, we have a map. I'm not going to show it to you today, but we've got a map that shows where Aggies and folks that have been through TTI have ended up, and we're scattered around the U.S. quite a bit. Our traditional client base has primarily been public agencies, but that's changing in the past decade or so to include more private companies, and in fact, to include several data analytics companies. So one of TTI's longstanding strengths, and one that I like to emphasize, it's in our mission. It's to develop practical and innovative solutions. I want to repeat that: practical yet innovative solutions. So most universities and national labs are sort of down here on this end, where their focus may be more on knowledge discovery and basic research, with not a lot of thought or effort put into how that knowledge and those research results gets put into practice. But we at TTI like to say that we bridge the gap between the innovative research on this end and the practice on the other end. In some cases, yes, we do basic research, but our focus tends to be more on applied research. And in some cases, it extends into developing tools. And so that's a great segue for what I'd like to talk for just a few minutes about today, which is focusing on the end user when we're building data analytics tools. Let me first say something about big data and transportation, because we really do have sensors everywhere. They're generating more and more data. I mean, we've got sensors in our roads. We've got them in traffic signals, like you can see here in the graphic to the right. They're in bridges. They're even in some of our more advanced traffic signs. We're definitely have sensors in some of our newer vehicles, whether it's a car, a train, a truck, train, bus, bike, scooter, whatever. You know, if you've purchased a new car in the last 5 or so years, there's probably a pretty good chance that you're sending some of these things up to the cloud. We're carrying and we're wearing sensors these days, whether it's smartphones, whether it's our watches, maybe even I saw this the other day, a posture sensor for those that are sitting at their desks a lot. And when I say that, I always tend to sit up straight. I saw you sit up straight, Janelle. You were slouching. No joke, my lab doodle even has what's called a fit bark that sends me notifications when it's time to walk her. Whenever she's not meeting her activity goal. I mean, we've got sensors everywhere, shipping containers and pallets. It's on our packages. One of the emerging trends that we're seeing in transportation is who is generating and gathering and owning a lot of this data. More and more data is being created in the private sector. And that can be a bit disruptive for government agencies who are used to collecting and owning outright every single piece of data that they use in transportation analysis. So how do we serve up all of this data to transportation practitioners? So there's a common joke, type of joke in the US that starts out like this. It goes, so 3 people walk into a bar, but hey, this is a work webinar. Janelle told me to keep this, it's got to be safe for work. So I'm going to change this up a little bit. So you've got 3 people walk into an internet cafe and the waiter asks them, well, how would you like your big data served? Well, that first person that walked in just happens to be a farmer. This farmer, she spends a lot of time harvesting the same crops, right? She sticks with what she needs to get the job done year after year. She doesn't necessarily experiment with a lot of new crops unless there's a guaranteed yield. So what does she ask for? Well, she's going to ask for fixed reports, stuff that contains just what she needs. Don't throw in a bunch of extra information and visualization. That's going to make it harder for her to find her main cash crop. Second person that walks into that internet cafe is a tourist. Now, this tourist, she wants to see things that they've already been discovered, but they're new or they're different to her. So she generally knows what she's looking for, and she kind of likes to stick to the main sites. But her travel partner likes to venture off the beaten path a bit. So what does she ask for at the internet cafe? Well, give her some extra tidbits. Make her visualization, make her information a little bit more interactive, right? She wants to see the main thing. Maybe she wants to get off the beaten path, but don't make it so complex that she gets lost in a narrow alley after dark. All right, the third person that walks into the internet cafe, we've got our scientist. Our scientist wants to discover some completely new things that have never been seen or known before. This scientist, he's not afraid to go way off the beaten path, and he likes to do different things. He likes to combine information and clues in new and different ways. So we have to give this scientist lots of flexibility to explore raw data sets in unique ways. He doesn't want the same thing that the farmer or the tourist has ordered. So hopefully y'all are seeing where I'm going with this simple metaphor. I want to show you several of the analytic tools that TTI has built and sort of show you how we've tried to build these tools around these 3 types of users. And in some cases, we've built different features in that same tool for these different users. All right, the first example is one of our simpler tools. It's a statewide database for bicycle pedestrian counts. Many of the cities and regional planning authorities in Texas, they're starting to collect more and more bicycle pedestrian counts, but in many cases, they're keeping the data in Excel files. They're keeping it in these isolated databases. So we're starting to put this all together. We're trying to make it easier for folks to get to. I'm taking the risk averse path. I'm not going to do an actual live demo. I'm going to play a recorded demo. So let me show you that, and I'm going to talk about it and tell you a little bit about what I'm doing. So let's pretend I've went to this visualization. I'm a city planner in Austin, right? And I want to go and I want to get a few basic facts about this busy trail bridge over Lady Bird Lake that's right near downtown Austin. Okay, so we pop up the visualization, we find the site that we're looking for, and bam. Well, the farmer in us looks up to the top left, right? That's where we typically start reading a page. We see some basic stats. We see, weekends are busier than weekdays. We see over here on the time of day, the mornings are slightly more popular than evenings. So these are basic facts. These are the cash crops for a farmer. However, the tourist in us wants to explore a little bit more. So we're down to the bottom where we can, well, you could have seen, or earlier it showed day by day detail. We click a button, we want to zoom out a little bit. So now we're looking at week to week detail. And then maybe what we want to do is we want to filter in to a certain specific time frame that we're looking at. Okay, so in this visualization, we put in a few things for farmers, we put in some things for tourists, but then there's one thing that we put in that I didn't show you that's down at the bottom. Hopefully you can see down here, there's a little download button that we put in for scientists. And we've had some scientists show up at our website and say, I like your viz is pretty cool, but just give me all the data for the site. And so we say, hey, you can go down here and you can just punch and click and download what you would like. So that's one of the tools that we've built. Let me show you the next tool. Okay, and so the next tool you may have heard about is our urban mobility report. So we just released our latest urban mobility report last week. If you're not familiar, it ranks congestion and congestion impacts in the US in 100 or so of the largest cities. So we're using enriched vehicle probe data as the basis for this. And I mean, this is truly big data, as big as it gets. Enriched probably gets billions of data points from GPS devices on a daily basis. Needless to say, in our urban mobility report, we get lots of tourists, and these tourists are mostly non-technical news media, because the news media want to write a flashy headline and they're looking for stats to make their city look worse than other peer cities in a certain category. So let me show you a little bit about that. Let's say in this example, let's say I'm a freelance writer who I used to commute to Manhattan every day, but now I write from my living room in suburban New Jersey. So I want to go in, I want to I'm looking at the East Coast. I want to see what's going on in New York. All right. And I want to see how that compares with other large cities. And well, I've written stories on the mobility report before. So as a farmer, I know to go to these static tables first. I'm used to seeing those. I can quickly grab. I need to catch up and talk faster. But now I'm a tourist. I'm looking for other information. I'm looking for a new angle that I want to highlight, right? And so I go and I find the graphic. I go down to download, and I can, as you see here in the animation, I'm downloading a little bit of extra things as a tourist. And so the tourist in me isn't quite done. I want to look around a little bit more. I've looked at New York, but I kind of want to look at some other cities, other city sizes in the Northeast and in New England. And so I'm going to look at medium-sized population cities, 500,000 to 1 million, and I want to see some stats for them. And so on. I think hopefully you're getting the gist of this and accommodating these different types of users. So this is another example that's probably getting more towards the scientist, and you'll understand what I'm talking about when I show you the visualization. So this example, so TTI studies big data in air quality environmental research as one of numerous areas. Some may not realize it, but a major source of air pollution is from truck idling. And so in some cases, truckers are just idling their trucks for hours just because it's a convenient source of power, right? And so we were able to get second by second truck movement and engine data from a sample of trucks that's operating in the Houston area. And we created this visualization for the Houston Galveston Planning Authority to I guess be a scientist with this truck idle data. Whoop, let me go back. This animation is going to automatically start. So this first dashboard, let me restart that. It actually started in the middle. So this second part, really, this shows the origins and destinations of truck trips from the data, and it shows the hourly distributions. Here's where we should have started. So this shows the idling events. It shows, you can see up in the upper left corner, the idling events by day of week, by terminal. Over here on the right, you can see we can zoom in, we can look at specific terminals. And so there's lots of details here. I will tell you, one of our researchers sent this to me, and my first thought was, oh my gosh, I'm overwhelmed. There's too much going on here. He explained it to me. He was a tour guide, and he helped me understand and basically pointed out the features. That's the thing that we need to understand when we're creating complex visualizations like this. Are we building this for scientists? Are we building this for explorers? Or are we building this for tourists? And are we going to get our tourist loss if we build too much complexity in our visualizations? One more quick example, and then I want to pass it on. I don't want to take too much time. Sometimes on smaller research projects, we have a narrow focus on a very specific problem. And we're not asked to develop this full-blown analytics tool, but instead, we're developing an implementable traffic engineering solution. But big data plays a large part in that solution. And so one of the things that we've been asked to help the Texas State DOT on is various safety problems in one of the busiest energy development areas in the US, which is out in the West Texas oil fields. And so instead of a standard engineering or research report, we use, you may be familiar with them, they're Esri story maps to provide the right mix of static and interactive graphics for both farmers and tourists alike. And so you can see in this example, let me pause it for a second, we're using connected vehicle data. So these are newer modern vehicles. They're currently about 5% of the traffic stream. They're reporting their location every 3 seconds over cellular. And they also report certain events like hard braking, fast accelerations, even seatbelt clicks, believe it or not. We also had some telematics data from instrumented fleet trucks to help round out the sample, since a lot of the connected vehicles are from consumer vehicles. All right, so that's the background. So this first graphic shows sample size over 6 months that's centered around one of our particular study corridor, which was Highway 302. So some of the other graphics show you the inputs to our traffic safety study. We use both traditional crash counts, but we're also looking at high rates of hard braking along the corridor that we've gotten from connected vehicles. Ultimately, so we presented several of these inputs, both on urban and rural segments. Ultimately, the researchers identified several driveway consolidation locations based on the data presented in this story map. And so it basically came down to good old-fashioned access management, but it was made possible quickly through big data. All right, so that is my last example. So I hope these examples have been illustrative, and I hope that you'll think about these 3 types of users as you build your big data analytics applications. Hopefully it was apparent in my examples. I don't think you can expect just one type of user unless you have a very narrow focus. In reality, I think you're going to have different types of visitors. And I think we need to be able to accommodate these different needs and preferences. We need to remember the farmers. We need to remember to make those basic statistics and high-level summaries, make them easy to find and access and download for the farmers. We need to give the tourists some freedom to explore a bit, to get off the beaten path, maybe to see something interesting in the back alleys of our big data. And finally, we need to make it easy for scientists and other power data users to easily ditch our cute little interface and take our data into their lab of choice, where they can integrate it with other data sets and where they have the ultimate flexibility to make totally new discoveries. So I do have the visualizations. These are online from what I presented today. I think Janelle's going to send out a PDF afterwards, so they'll be there. I've also included some of our other visualizations. If you're an explorer or a scientist or a tourist, you just want to look around, I've got that in there as well. So thank you for your time. Janelle, thank you for inviting me, and we're happy to talk after Andrea's presentation.
Yeah, thanks so much, Sean. It was really great to see all the different examples and the good stuff you guys are working on at TTI. And I know, speaking as a person who's been a scientist and pulling your data, it's nice that you make it very accessible for us. And it says, as I would say, among the many states who offer it from a DOT level, it's really great when you can make things readable, understandable, being able to download, work with the data. That's certainly important. So yeah, it's really, really great work. And we'll definitely, hopefully we can get some questions from people. So feel free to send questions in. We'll have some time at the end to talk to the panelists, ask questions. And then obviously we'll send out Sean's presentation, so you'll have those links. So with that, I'm going to hand it over to Andrea, who's going to present on Accurate.
Sure, let me share my screen. Okay. Can you see it? Okay, great. Thank you very much, Nell, for the introduction. And okay, so beyond the statement you read on my screen, on my presentation, probably telling you something more about my background will help to more easily understand Accurate's approach to the universe of data visualization. In fact, I'm a former architectural engineer, but despite my highly technical background, I'm very keen to work in creative environment as a designer, of course. At the beginning, I was just very passionate about technology, and lately more and more fascinated by the extent of innovation that can be generated in this kind of environment around the connection between technical, creative, and business-oriented disciplines. And connecting this kind of disciplines is exactly what we do in Accurate. And in fact, what we finally brought me in Accurate is the awareness that today data are the common thread linking various disciplines that before were considered as far from one from the other. And for this reason, research and businesses around data, in my opinion, must rely on a wide range of expertise that requires multidisciplinary environments to excel, but also to be successfully orchestrated. And that's why in Accurate today we are data scientists, front-end developers, UX and UI designers, architects, sociologists, musicians, biologists, and many others. So there's a huge mix of competencies, a lot of discipline, collaborating together around this huge topic of data and data visualization in particular. So the result of such an alchemy is what allows us to foster our philosophy in developing data-driven solutions, that is the data humanism. So what does it mean? We believe that data need to be approached from a human perspective. So we push to emphasize with them by not just looking at number they represent, but focusing on the action and the interactions implied by those numbers. Therefore, if you want to understand data, we believe, and if you want to understand what data can tell you, we believe that you need to ask them the right questions. But at the same time, we are aware that what humans define as the right question is always very personal and subjective. So for us, it's very important to be aware of this and to make our client aware, because we don't see data like an oracle telling us the truth. It really depends on what kind of answer you want to get and on what kind of question you make them. And this is a very iterative process. You need to start exploring, then adding more context to data to understand them better, then re-explore around them, and so on. So how do we translate this approach in our daily work with clients? And I would like to start by telling you, giving you a general idea of data growth in recent years. In 2018, the total amount of data created and captured, copied, consumed in the world was around 33 zettabytes. This grew to 59 zettabytes in 2020, so yesterday. And but this is about to be tripled in 2025. So we can definitely say that, unlike a few years ago, data availability is not a problem anymore. And also they are all also more and more accessible. So this is solved in the most of cases. Meanwhile, more data experts are flooding into the market. We are talking about 7.6 million professionals all around Europe in 2019, that will reach 11.3 million by 2025. So the real question should be, why do clients from all over the globe choose to trust and work with Accurate to develop any possible kind of data-driven projects? So while I answer to this question, I send on the background some images of the project we have done in the recent years. So just to give you an idea of the diversity of the visual expression we make. And then I want to tell you that, of course, as you know, more information means also more complexity. And for sure, scientists and analysts can make a big quantities of data more and more digestible by applying techniques. Many kind of techniques. However, in our experience, this is often not enough to provide meaningful results for the end user. That's why we try to work very closely with our clients and with their data expert, who knows much better than us how that data are done, what is the potential, to understand the context in which data are generated and interrogated. Then we start developing digital, physical, hybrid experience based on such data that are 100% oriented to specific targets. And this is very similar to what Sean was saying before. So thank you, Sean, for anticipating this. You are helping me a lot, because we are really on the same page on this. We try to create very tailored experience around data that are always different, and these also give us the possibility to make a continuous research on each project, which brings to very different results. And also I prepared two examples, actually, two case studies that are two projects we have done in the recent years. And I want to drive through them because they are both based on very similar data. We are talking about flows data in indoor large-scale environment. In one case, we are talking about airports. In the second use case, study, we are talking about shopping malls. So we have the same kind of data, but a very different perspective on that, which brought us to build very, very different solutions. So the first one is a project that we have done for a company consulting the Transport Security Administration. in US. They were asked to solve a problem they had around the static reports on security in airports, because they were based on a very analytical approach, very standard visualization, and they basically had a huge lack of explicit suggestion on how to manage space, and the lack of forecast on which the criticism could be according to the situation in real time. So what we have tried to do for them, we have since some very specific KPIs were already defined, we tried to give a different drill down on these KPIs in order to easily find criticisms and get some hint on how to solve issues in real time. So I've also prepared a video. Okay, so in our solution, we start from a general screen showing the situation in real time all over the country, and a general rule of what we've done is then that whenever you see a blue KPI, it means that that KPI is going well, is performing well. The red one is not performing well, so can require a further detail to understand what is not going on and how you could improve the situation. So by starting from here, you can select a specific airports. Then once you are into the airport, in this case, we are on the San Juan Luis Muñoz Marin International Airport, you have two kinds of visualization. The first one is a sort of executive summary where the main KPIs are shown in this. So it's let's say a sort of collection of all the most important information, but you also have another view that is the operational summary, and I think is coming now. Okay, in the operational summary, you have a better breakdown of how operations are going on, especially on what is the turn-up profile of each of the airport versus the passenger process, because this is the main issues in managing security in an airport environment. So from this visualization, you can get more detail related to the general performance of the airport, but you can also have a look into the detailed information of each desk and each lane connected to that desk. So this visualization is something you need that must be read from the bottom to the top. On the bottom, you see the amount, the volume of people in every single desk, and then how you see how that volume is divided among every lane. Then you also get all the information related to that lane is performing in every single step. You also have detail on how the flows are dividing and how they are, and some forecasts on how that lane will be in some time. You can decide the amount of time, so it's easy to make forecasts on alternative scenario, and to understand how you can better balance the passenger traffic among all the lanes. And this is let's say the first one. Let me jump to the second one. This is a project we have done for RCT. They are a technology leader company in people counter, and they had they have this technology that is basically a people counter they install into shopping malls that they sell from many years to the most of the shopping mall in Japan. So they have a very large amount of clients, and which you not only use their technology, their hardware technology, but also software, which was called Rainbow. That was, let's say, a very old-fashioned, software with a very with no appeal on the market anymore, a text-heavy interface with it required time-consuming customization, and in general, it didn't host easy-to-use database. So for them, this software was really a pain point, because if the technology on one side was really cutting edge, on the other side, the software was very bad performing, and it was a problem for them also from a sell point of view. So they called us to ask how they could better redesign their software, and how they could also evolve it and integrate with the already existing system. And this was a real challenge, especially because we were dealing with a client from the other side of the world. The entire interface was written in Japanese, so for us it was impossible to understand anything without further explanation. But it was a beautiful project that we started developing by having many interviews with all the people inside the company and many of their clients, in order to understand what was working well on the old system and what was needed some fix, both from an interface point of view, but also from an architectural point of view. So let's give a look to the interface. As you have seen in the previous slide, the work we have done on the information architecture has been huge. We simplified a lot, but what we have understood from the interviews is that their main issue was to have an easy view of how volumes were, how the space were performing in a specific time frame, and they needed to have the possibility to make comparison among space. So we have developed some custom visual model to visualize that data. That is this kind of circular visual models that is showing, in this case, the colored one. You will see a colored one and a grayscale one. They are both showing volumes. So they compare in a specific time frame, that is the one that you select here on the bottom. They compared, in one case, the males and females volumes of people passing by each sensor, and in the other case, the grayscale one, this one, they compared the incoming and outgoing traffic. So, of course, while you select a different time frame, you also update the visual models, but you also have some additional information on it. It's something you can see here on the bottom left. In fact, in this case, we are highlighting through this through this bar, that a specific event or weekend were happening in that moment. And for them, this was a key information also to easily read how the volume were performing in that specific moment. And so this was the pivotal change we have done on the visual model point of view. Then on the general interface point of view, we had collected and all the KPIs here on this panel on the right in order to make them easily accessible and comparable. So you could select and filter, you could select and filter these KPIs and update in real time all the maps in order to make easy comparison and so on. An interesting fact is that we also started mixing different kind of KPIs. So for example, a very good one, in my opinion, is the one comparing the online marketing campaigns with indoor traffic measurements in order to calculate a sort of conversion rate between these two words that are usually very totally separated, but actually we're allowing them to measure something that nobody had measured before. So they really changed also the commercial offer because they were showing something more than before to their clients. So just to wrap up, why did I choose these two projects? I think that I was saying before, the starting point was really similar, but in one case we had the need to give the possibility to understand on real time very quickly where the criticisms were and how to resolve them. With similar resources, in the other case, we have done something that is totally different because we have built something that is very powerful if you want to analyze in, let's say, the historical performance of a place in order to understand how to better manage it on a long-term strategy, not on real time. So the kind of challenges were very different and required a very close relationship with our client to understand it and to develop our solution, a solution that was really solving their some real issues. I hope I was good with time, so I finish here. Then we will talk later.
Yeah.
In the question.
Thanks, Andre. It was really great. Certainly great visuals, and you guys do really interesting and neat work. So yeah, thanks for walking through those case studies that you guys did. So I was hoping we could spend some few minutes to take some questions from people and just to kind of talk a little bit about both of your presentations, because I think when we were putting together this session, we had a chance to talk to both of you, and we were really focused on, you know, the title, which is, you know, the data should not be standardized. And I think you both have touched on a little bit client aspects, and Sean, you touched on the types of users, the farmer, the tourist, and the scientist, which is now permanently in my head because those are you gave nice descriptions for those. And so just listening to kind of both of your presentations, and kind of, Andre, you also talked about this, the client aspect, and maybe Sean, for you, like, would you say that there's maybe one type of user for whom it's, you know, easier to design these tools for? Is it somebody you're really thinking about when you're putting everything together to make it more accessible or easy? Or maybe you want to touch on this?
Sure. Yeah. So you would think, right? So a farmer has very simple, pretty basic information needs. You would think that it would be easiest to design for that. And it is. I think the problem or one of the challenges that we have as lovers of data is that we think we have to make it more complicated than what some of our users really want it. And so I think we in several cases we've gone down that path with a tool where we want to give all this flexibility and we want to let them do this and this, and we have to back up and say, wait, who's going to be using this? Have we addressed the basic 1, 2, 3 needs that most people, and then we can start working on some of these edge cases, or we can work on some of the tourist needs. So yeah, I think that's that was hopefully clear in my message is let's not, because we do a lot of applied research and we work a lot with practitioners, let's not forget the basics. Let's not get so enamored with the razzle dazzle and the cool viz that we don't forget the basics.
And are you guys getting any, guess maybe any indication of who is using your data in terms of like what their actual profile? Because I think I told you, I would fall into the scientists, from pulling down data and working with it, like you said, because we're putting it in presentations. And are you getting like general public, we're like, oh, this is all jargon, I don't understand it, and we need it to be more understandable? Do you have any kind of indication on who your customers might be?
In some cases, yes. In I would say in many cases we do. Part of it is like, for example, I'll talk about our urban mobility report. So that's something that we put out, and even you mentioned it. I mean, a lot of people grab that info. A lot of people consume that information. But in the course of getting that information out, talking to the news media, we sort of in phone and now in face-to-face conversations, you can get a pretty quick sense of what are people comprehending, what are they asking questions about. And we track the stories that are written, we see what they're getting accurate, things, common mistakes or things that they're misinterpreting, we try to go back and fix. And I think that's a good practice. It's difficult whenever you don't have feedback on how your information is being used. Just like webinars are difficult when I'm not getting audience feedback. Hopefully everyone's staying awake. But you need feedback. It's very challenging if you're just sort of throwing information, throwing data over the wall, and you're not getting anything back.
So maybe Andrea can comment about this, because his relationship is a little bit different, right? Because you talked about Andrea, like you're working directly with the client. The client is kind of telling you their needs. I mean, maybe you want to talk about like how you're working with clients to kind of make data digestible for them. And maybe you just want to talk about like the steps that you go through when you're preparing, the TSA, for example, or the other example that you showed us.
Yeah, definitely. It's not just a matter of how to make data digestible, but the entire experience around them. And we make these on 2 levels. The first one is for sure the one you have already mentioned. So we work closely to our clients. We get their feedback during the development process. So these are all very precious feedback. But especially when we talk about products that our clients sell to someone else, a second level, it's a kind of user research we make on the product itself or on an MVP of the product. That it's a very important moment to challenge all the assumptions you have done about the readability of data, the meaningfulness of that information for that people in that context, in that moment. And that's a very important moment, because we not always are able to have this kind of experience during a project development process. But when we can do it, the results are much better. And also in terms of maintenance of the service, it's much easier to evolve the product in time, because you have a very clear pipeline about how the user would like to enhance his experience on that kind of information. So you have a very clear indication of on how to evolve your solution. And this is something that is not easy at all to explain to our clients, because it's something that is usually considered not necessary. But we are gathering more and more let's say case studies on that. So we hope to do this more and more in time, because it really pays very well.
Cool. So I unmuted Rawad. He wanted to ask a question. Maybe Rawad, can you test? Did I unmute you properly?
Yeah, can you hear me?
Yep, we can hear you.
Okay, hi. Thanks again for the wonderful presentations. I have a question that I mean, it starts from the point which can be a question for both Sean and Andrea. I'm talking from a planner's point of view. Very often we face this problem. Big data is very interesting in reading the status quo, reading current phenomena, and then when we start using it to do planning, forecasting, we tend to go back somehow to our traditional ways of looking at this. So my question to Sean would be, if you were to give an advice to a planner, should the planner take the farmer's approach and look for simple data sets, or the tourists go explorative, or the scientist, which is complex and comprehensive, or all of the above? And my question to Andrea would be, how much you think visualizing data alternatively is a medium to plan and to think out of the box and to seek some alternative solutions that you wouldn't and you cannot see just by having the data, but while visualizing them, you can just see new perspectives, and you can bring a lot into a planner's world. Thanks.
Yes, so thank you for the question. So I think my answer will be, it depends. It sort of depends on a case-by-case basis. There are times where, yes, I wish farmers would be more inquisitive. I wish you would ask for more than just the basic facts. And in fact, sometimes that's what we will do, is we'll say, okay, here is the facts that you wanted, but oh, by the way, here's some other tourist sites that you might also consider as you're gathering your crops. And one other thing that I will add, that I really think it's important when we use big data for planning, is big data tells us only what we're doing right now, not what the future has to be, right? And so I think sometimes we get wrapped around, well, this is the way that things are happening now, and we're just going to continue that. We might, one of the things that we work on is trying to make streets more multimodal. And well, big data tells us that there's not many people that are biking and walking on these streets. Well, yeah, hey, guess what? There's a reason for that, because some of these streets aren't designed safely for that. And so just basically keeping that in mind, that data is a reflection of where we are now. Planning is about where we want to be in the future, and not letting where we are now constrain where we want to be in the future.
Yeah, right. Thank you. I totally agree with you.
That's a great point too, Sean. And maybe a follow-up, and maybe Kevin can also chime in. I see that there's 5 Kevin Halls on here. But how do you, I mean, you guys, at TTI, you guys are collecting this, you're kind of at the source, almost the source of the fountain at this. And how would you say you see data solutions kind of evolving over time? I mean, what you showed me from now is, kind of almost light years from when I last looked at it, I guess in 2016 or so. So how would you say you see this data solutions evolving over time?
I'm gonna stall for Kevin while I don't know if he wants to weigh in, or whether you want to promote him. So Kevin and his 4 clones work very closely with Texas State DOT and applying this passively collected big data, the smartphone and LBS. And I will say, from my vantage point, I think one of the things that we're trying to do is we're trying to get the use of this into routine production, while at the same time we're trying to take advantage of new data sets that give us more and better insight. So it's kind of like, I guess I'm full of metaphors, but it's kind of like upgrading your airplane while you're flying it, right? TxDOT has to run these demand forecasting models all the time, but at the same time, we're trying to improve how we're calibrating and how we're getting the inputs for these models. And new data sets are becoming available. And so it's a challenge for sure.
Yeah, I just will read. So one of Kevin's clones, just an observation, often there's a gap between data as being used for a project and that being sold as a product. A data sold as a product with or without visualizations is oftentimes restrictive for some downstream analysis. It is valuable to understand across clients on how it is being used, ranging from as reference to reports and studies to inputs for further analysis. Yeah, I think this is a really great point, because data sold as a product, and then you get that product, speaking from experience, and then you don't really know, is this the integrity about this data, where it's coming from. You have to really do a lot of data mining with this. You're almost like the PhD scientist to try to figure out what it is you're actually looking at, and hoping that there's some sort of integrity with this. So thank you for that.
Yeah, Janelle, can you hear me?
Yep, we can hear you, Kevin.
Oh, wow, it's working. Yeah, VJ beat me to the point. Is one of the challenges we're having in the travel forecasting arena is we're buying data that's already been pre-processed. And so, what have they done to get it to the point that they're selling us the product that VJ is telling us? And so while it's I've said this before, it tends to be a whole lot more information about a whole lot less, if that makes sense.
Yeah, that's interesting. So then I guess maybe, we can, Andrea, I don't know if you want to chime in on this too. I mean, we, I think, talked about how you're collecting data, and are you getting like rich sources of data from your clients, or are they reaching out to other data vendors, or what is kind of the sources that you're using to put together your products?
Actually, there's not a general rule. Many times we work with the data provided by our clients, but we always try to add something more. So if we are developing project that in some extent touches something that is outside the organization, so we can increase and improve the availability of data, of context, we try to do it. This is not always possible, but we try to do it. When we have developed urban project based on urban data, we have sometimes both information from data provided. We have used, and we are still using a lot of open data, and they are a very precious resource. But of course, there's a very big challenge in merging together all these sources in order to have some kind of some time of integrity in terms of granularity and so on. So you need, while merging all these sources, you need to make a big work of fine-tuning in order to understand what is meaningful, what is not, because it's something on a totally different level. And this is not easy at all. So if you can do it with someone that is, let's say, that knows very well the disciplines, the way how that information need to be used, it's much better. And this is also cause having so many different background inside the same company. For us, it's super useful, because you can talk to microbiologists whenever you are developing a project in the pharmaceutical field, and with the financial expert when we are working for a bank. I'm an architect, so this is really something beautiful, because you can learn a lot by facing this challenging.
Yeah, interesting.
Hey,
So I
Janelle,
know-
can I
Yeah.
circle around to what Sean was talking about earlier about the farmers? I mean,
Sure.
we just did a bunch of what we thought initially was some incredibly robust graphics, and they were interactive and they were awesome for a major project here in Austin on IH35. And we showed it to some people that are in the transportation industry, but are not modelers or not, engineers and all that good stuff. And their initial reaction was, we don't understand. And after getting through the soul crushing defeat that you go through, anyway, as we engaged them and got their feedback on how to present this data, it became patently obvious that what we thought is normally a good way to present this information was not a good way to communicate to a vast majority of the end users of the system. So yeah, to Sean's point and everybody else's point here, at some point you really do have to get feedback from the farmers first almost. So, but the product in the end is much better for it.
Yeah, and it reminds me back to Andrea's slide too, when he showed the data humanism. And I really like that slide because he kind of he crosses out a lot of things. Big data, I think he makes it small data, and data is really about people and really trying to bring the data down to like being digestible and really trying to think of it from different perspectives. I mean, when we're kind of, Sean, you mentioned being data nerds, so I'll use this term. When we're data nerds, we're seeing this stuff every day, and then you go to try to present it to the public, and like you just said, Kevin, they're the what? I don't understand. So it's certainly an important thing to remember of I guess getting feedback from the clients and the customers on what it is that we're showing them and helping them understand. Because at the end of the day, right, we're most of the time we're preparing this stuff for decision makers and for people to kind of, it's affecting people's livelihoods in some cases. I-35, of course, very important. So you want to make sure you get that one right for those decision makers.
Yeah, in the end, it got better. It got much better. But yeah, that initial shock of like, why you don't understand this? But it really became an enhanced product by getting that feedback and reacting to it.
So are they gonna, what's the status of IH35?
Oh my God, that's another Sys Talk.
Okay, we're gonna hold you to that.
They want to bury it through downtown. Actually,
okay. Highway removal. That could be a good Sys Talk.
And one of the alternatives being discussed is to actually remove it and convert it to the old boulevard that it used to be.
Okay.
So, yeah.
We can assist.
Talk about big data. That's a big model to run. Anyway.
So I'm going to open it up if anybody else has any last comments or questions. We're nearing the end of our first Sys Talk, so I want to be respectful of everybody's time, wherever you're calling in from, if it's going to lunch or going to dinner. And, if there's nothing else, then I'll go ahead and close our webinar. And I want to, I guess, thank everybody for attending, taking the time out of your day or evening, and our special thanks to our guests. Presenters.
Thanks, Janelle.
It was a pleasure.
Great.
My wearable sensor is telling me that it's time to stand.
That's true.
It just told Apple that I've been sedentary for the past 90 minutes.
Thanks, everyone.
Okay.
Thank you.
We had a good reason. Thanks you.
Thank you. Thanks, everyone. Take care.
Take care.